NCBM 0324, Section 1.7, Solving Quadratic Equations with the Quadratic Formula, Part 3. Let's practice some more. We're still in example 1. We're still using the quadratic formula to solve the equation. But let's look at Part C. C looks extra fun because they have our favorite things, fractions. Okay, we have 1/8 x squared plus x minus 5/2 is equal to 0. So technically this is in the right form. We have our a, our b, and our c is equal to 0, right? We have that equals 0 condition. But those fractions are going to make the calculation pretty messy. That's not to say we can't use the quadratic formula in this way with these values, but it just might be a little bit more involved because we're doing fractions and we have to maybe square some of this, multiply, add fractions, which always takes a little bit longer. So let's think back to what we may have seen in a previous section earlier in the unit. Well, when we were talking about equations in one variable and we had fractions, we were able to clear off the fraction with that LCD, with that common denominator. And because this is quadratic, doesn't change that. We can still apply the LCD to clear out my denominators. So in this case, I want to look at the 8 and the 2. My 8 and my 2 are my denominators. The x has a denominator, but it's technically a 1, so we know that's pretty it just kind of goes along with the denominators. But the 8 and the 2, between those, my LCD would be the 8, right? I can get them both to be an 8. In other words, if I multiply 8 times both sides of my equation, that's going to get rid of my fractions. So I have to distribute. I have to multiply every part of the equation by that 8. Well, when I do that, 8 times 1 over 8 is going to leave me with an x squared. It would be 8 divided by 8 is just simply 1. Then my next term, 8 times x, well, that'll give me 8x. And then 8 times a negative 5 over 2. Maybe I want to do that as scratch work. We'll do that over here. 8 times negative 5 over 2. When I'm multiplying fractions, I multiply straight across. 8 times negative 5 is negative 40. Divided by 2 gives me a negative 20. So I have minus 20, and then 8 times the 0 is still 0. So by clearing out that LCD, clearing out those fractions, we have an equivalent equation. This new equation we have is going to give us the same answers as the original, but it's so much nicer to work with, right? We don't have any more fractions. My 20 is a little bit large, but I can still deal with it, right? Okay, so then let's go to the quadratic formula. I need my A, my B, my C. So A looks to be 1, so it's a 1x squared. B is the positive 8, and C is the negative 20. And then we plug into the formula. We have negative B, so I have negative 8. The 8 was positive, so the negative from the formula is the only one there. Plus or minus the square root, my B value squared, minus 4 times A is 1 times C is negative 20, all divided by 2 times 1. 2 times the A. Okay, it's looking good. Filled everything in. Now comes the order of operations. So I'm going to work on the inside of my radical here, my division, my square root, I should say. 8 squared is 64. This negative with that negative is a plus. So 4 times 1 is 4 times 20 is 80. All divided by 2. Okay, so then we'll have x is equal to -8 plus or minus. 64 plus 80 gives me 144 divided by 2. And the square root of 144, well, that's one I know. That's simply 12 divided by that 2 still. So at this point, we're ready to break our answers apart. We know that plus or minus is going to give us two possible solutions. So -8 plus 12 divided by 2. And x will equal -8 minus 12 divided by 2. And -8 plus 12 is a 4. 4 divided by 2 is 2. There's one answer. Over here, -8 minus 12, gotta do that first, is a -20. Then divided by the 2 gives me a -10. And there we have it. Nice answers coming from this original equation that had some fractions mixed in. If I wanted to check it, I would still do the same thing, take these solutions that we found, plug them in, and it should make that equation equal to 0.